so much for coming out, and thank you OWASP AppSec Kelly for having us. This is an awesome venue. I definitely want to keep coming back to this conference. Today we're going to talk to you about how we pose a threat. We have been penetration testers for 10 years. Before that, we were making security products, but like Oscar's been my partner in crime at this for a long time, and yeah, we've seen a lot. We've seen a lot of the common problems, and we really know like what it takes to like do this job at this point. But we're always looking to make it more efficient because we're lazy.
Very lazy.
So we've been working on some exciting new automation over the last 9 months to make us better, faster, and stronger. And we've been using the analogy that it's like an Iron Man suit for penetration testers. The objective we've really had is to like be able to continually refresh our knowledge of our target's perimeter and to be able to then rapidly identify issues so we don't have to spend as much time doing all the tedious stuff to go find them.
Yeah, so we automate the process of discovering domains that may be associated with an organization, subdomains that are associated with those domains, site ranges. We take fingerprint analysis of all those targets, do screenshots, and then do our perceptual analysis on it.
Yeah, it's really a new way, actually, at least from our perspective, to find these exposures. We're like marrying that perimeter intelligence with the analysis and having the bugs come to us instead of us having to go find them. It's way better. But specifically, we want to focus on some revelations we've had at the power of using screenshots. I know a lot of our, folks use screenshots in their analysis, but it ends up being a lot of chaos and a lot to work through. So what we're really talking about here today is turning that chaos into order and actually being able to sort things by visual similarity. And I think this is going to usher in like a new way to rapidly find lots of issues at once. Who in here is a penetration tester? Okay, got a few people, or has ever been a penetration tester, maybe in a past role. Okay, a couple more. Who here has like maybe had their application that they're responsible for security of penetration tested at the organization? Yeah, all right, now we're kind of covering everybody. Who's ever stolen, or out of the penetration testers, who's ever stolen an AWS key or secret token? Yeah, nice. I guess who's had their AWS keys stolen?
You don't have to raise your hand. Yeah. You don't have to raise your hand.
Or were you aware of it even if they were? We wanted to demonstrate the power and capability of this, and so we decided to target Elastic Beanstalk. Just for a quick refresher, if you're not familiar with what that is, it's an orchestration service that Amazon Web Services offers to easily deploy applications on these common web stacks. The most common ways you deploy it would be with like a zip file or
Docker container.
Yeah, Docker container or
repository.
Or just as part of your continuous deployment, you just would push your Git repo up there. To give you an idea of the scale of targets this has, this is like something that every like major organization is using. Lots of small and medium-sized businesses are using this. This is the type of like hosts that you'll see on this infrastructure. And one thing that's really unique about targeting this type of infrastructure for assessment is you can't really use the old tools and techniques of just going off of IP address. You have to use domains and subdomains because the IP addresses may change daily. As part of that deployment, they automatically have elastic load balancers in front of them. They're automatically, dynamically getting rotated for performance and for reliability.
A lot of them may be vHosted and require the domain in order to access the actual web content.
Yeah, and so with this massive attack surface, we really have to focus on domains. And then what type of issues would we be looking for? The same issues that real attackers use to break in. And in our 10 plus years of being professional penetration testers, one of these 5 categories has been probably involved in every breach we've simulated. It's like either the first step or like step 3 in the attack chain. So focusing on being able to automate the process of identifying these types of issues was really interesting to us. And typically, you'd have to, for something like a missing patch or a specific application vulnerability, you'd have to write a signature. You'd have to know what you're looking for.
So that works on small batches, right? You can write know of a specific path, figure out what it's on that path, what's supposed to be on that path if it is vulnerable, write a signature, and move on to the next one. It's kind of a balancing act of how many false positives to false negatives are you willing to manage, and you trying to, it's like a balancing act of trying to find the right regular expression to match the most.
Yeah, you can spend a lot of time doing that research and development. In fact, like Oscar used to do that for WebInspect. If anyone's ever used that web application scanner, probably how many days of your life did you spend like researching these and writing these signatures? But you still didn't find all the vulnerabilities, did you? No, not even close. With perceptual analysis, we can actually just need the path and not necessarily need to know what we're looking for, not need to have a signature. So what kind of paths? Like to thank our friends at Gray Noise, which is a up and coming like threat intelligence company, for writing some like super cool research API endpoints to query their data set of paths that real attackers are scanning the internet for on a daily basis. And so this is real attack traffic that specifically HTTP endpoints that botnets are scanning the internet for. That
every day. As soon as you put on a system on an IP address, it starts getting scanned by just general scanners.
There's thousands of these. And it really can be things like 1 week you might see it become the latest router firmware exploit, and that goes to the top of the list of they're seeing the most requests for this. So this kind of gives you an idea of like what we're talking about, but to do the research of what to signature on for each of those, like we'd take an army of people. So what did we do? We took those subdomains for Elastic Load Balancer, or I'm sorry, Elastic Beanstalk, and we took the paths from Gray Noise, and we made those requests. Using our Iron Man suit, we in total made over 88,000 targets receive. Like to focus the example, like we only did 10 paths, which is about 880,000 requests. 52,000 responses were 200 OKs and screenshotable, or like we wanted to focus on 200 OKs. 4,000 of those, then we were able to filter down to things that could be interesting. And then ultimately, we found 321 critical exposures. Never mind the 9 months of R&D and engineering effort and all of the research time figuring this out. But all said and done, once we decided to make Elastic Beanstalk our target, it was about 30 minutes to get these exposures. Things like these. This is like examples of like .env files that were exposed.
AWS credentials, database credentials, mail server credentials, payment processing credentials.
And this is just due to that nature of like when you're deploying with a Git repo or you're deploying with a zip file to AWS, oftentimes the hidden files like .env or environment variables were also deployed and still left exposed to the internet. So just to give you like a quick idea of the slice of data, like this is what we found in 30 minutes of effort once all this had been engineered. And the fact of the matter is real attackers are doing this continuously. And therefore, to step up our game as penetration testers and to be able to target really large organizations also continuously, we wanted to be able to go toe-to-toe with people that have big botnets. But instead, we can just use AWS services. Another path in that list of 10 that we want to highlight was /.git/config. This one you can signature for. But you still might miss things. Like, same with the environment variables. Like you could argue, yeah, I could signature for that, but you'd end up with a lot of false positives. And the fact of the matter is, like, this is where you really get into like a lot of compromise. Like we were able to, like this, in that example, I think we've done like 9.6 gigs of source code.
Just text, not images or anything like that.
And so the last graph you saw was just the .env variables that were exposed on the sample set of Elastic Beanstalk that we attacked. This is just the sample set of code that we were able to steal, and that had encryption keys, database passwords, more AWS keys. So that's what you can do with this. I want to back up a little bit now that you've kind of seen what we're able to do, and we'll revisit exactly how we did it in a little bit more detail on how it works. But 10 years ago was my first professional penetration. 10 years was like around that time too.
Yeah.
And this was my go-to tool to do this same type of attack. OWASP Dirtbuster was like the first thing I learned of like, cool, we can get a dictionary of paths. We can do a target and just blast it with traffic.
Really blast it.
Yeah.
Right? Like taking the problem with it is we would constantly take down servers, send too much traffic. The word lists that come with Dirtbuster might have some offensive words and languages. So
we had some clients like say, "What? Why were you making requests for those vulgar words?" And I think like we got asked not to use that tool anymore for that reason among the taking down sites.
Yep. Yeah. We came into a lot of problems, right? You would get your sites, your IP blocked, your denial of services, the box, or the offensive word list problem. Overall, we ended up just banning it at BishopFox. No more using this tool.
Yeah, it just got us into more trouble than it was worth. And I think actually I was still working on WebInspect at the time that I had my very first professional pen test, and this wasn't under NDA or anything, so I can kind of talk about this. We got like a gauntlet thrown down by the CTO of UPS to like, why do I need to care about web app security? Mind you, this was 10 years ago. People still needed convincing. And I remember like launching this on as many UPS sites as I could. And I actually got the entire Alpharetta, Georgia office of HP blocked by UPS, and people couldn't check their packages for something like 2.5 years, or at least the remainder of when I worked there.
Yeah, you left after 2.5 years. It was still blocked after that.
Sorry, guys. But it was as simple as like, all right, I get another IP address and keep going at it, and found really juicy stuff. Like for some reason in my word list there was /UPS and targeted cod.ups.com, cash on delivery. And that was a hidden admin page that was just a username and password field, and that had blind SQL injection in it, and started downloading images of signed checks from businesses that were paying UPS. And but that wouldn't have been possible to find unless we guessed this obscure path and found that hidden login page. Yeah, this is like a quick demonstration just for those of you that aren't familiar with this or haven't used it. This is what the network traffic looks like to the server of Dirtbuster. Just basically gets bombarded. Like this is
a single IP sending a huge amount of traffic to the web server, which is on the right. Every one of those dots is
a request.
An HTTP request, essentially.
So this is also why it's really easy to block. Like you can really just kind of see it coming from one IP, and then the IDS IPS rule will quickly block it. Let's talk a little bit more about how this works, because we're like building upon these techniques. Like typically these tools, and especially the ones that a lot of people have been using over the last few years, do what's known as like soft 404 checking, which would be you actually induce a fail case. You try to make a request to something that definitely doesn't exist, and you look at the content length, you look at the HTML DOM and signature that in a sense to categorize a 404 page.
Yeah, so you make a known bad request, and then you try to build an on-the-fly signature of what that request is, so that if you request another path that doesn't exist, you can try to match it back and remove that data set. So you end up with just good data.
Yeah, and for those of you like that may have used Burp Intruder to do this type of attack, you've probably done the like sort by content length, just sort all the ones that are the same length to the same edge of your table, and all the outliers of that then become interesting to look at. That really doesn't scale well though. It's really hard, especially if you're targeting like tens of thousands or hundreds of thousands of targets. They all have maybe slightly different and slightly unique 404 pages. So what do you do in that case? Or like maybe you start to have screenshots of them. And there's a lot of tools that people use this, GoWitness, iWitness, things that'll like let you make a static local version of your screenshots.
Yeah, so if you were to run a regular Dirtbuster, you'd come back with a huge number of paths to review, right? And the process is basically either look at the HTML content of it or click on the link. And so this is kind of me going through and reviewing. There was 4,400 screenshots or paths here to review, and this is the process that a lot of people go through.
This is what you're paying your penetration testers to do.
Anything interesting here? No.
Yeah.
Anything interesting here? No. There's problems with, I'm sure you guys run into it with HTTP sites that have the SSL certificate broken in Chrome, and you have to click accept to get the content. So it's a very slow process to go through a very small list.
Way too many hours of our life doing this.
Yeah. Probably 10 paths a minute of going through the content.
Yeah, this is something that like ultimately I'd say that this is pretty much the state of the art. Well, like
It's right before.
Yeah, maybe right before like the most advanced technique that
Something
that are
like
used today.
Eyewitness or GoWitness to go take kind of bulk screenshots, maybe.
Yeah, but we really think like humans aren't cut out for this tedious task. Like we really wanted to
I'm not cut out for it.
really want to see if we get some robots to help us out because it truly is like a needle in the haystack. And we thought long and hard about the problem cases, and it really does come down to inconsistency. Like little dirty secret of like the penetration testers you're hiring probably aren't doing this consistently, especially if you have a large attack surface. I guarantee you every penetration tester does not do this on every target just because of how tedious it is. You also have the problem of like data divergence. If you have a team of people, maybe like you've purchased a penetration test or been part of a team because the attack surface is so big, we're like, we'll just throw more people at the problem, just ignoring the mythical man-month issues with that of more people means just more time and communication and coordination. So like, what's it like trying to manage 2 different data sets on 2 different computers?
Yeah, so I mean, you start off, you run a scan, your partner in crime also runs a scan. Now you get 2 data sets that you're running. You have the problem of getting updates to your data set. So hey, we just found these 30 new domains or these 30 new hosts. We got to go scan those and do the whole process again on that set. Now you have your own data set is all fractured. You have multiple scans of the same data, and you have to go through the whole process of looking at all those paths again for each one of the every time you find a new target. And so that becomes very painful, especially on long-running engagements with a lot of different consultants.
Yeah, and it ultimately, like the more targets there are, just takes too long, and it never. That's one of the reasons it's done inconsistently. So, as we really thought about like where are the pieces of the process where we could reduce time and labor, this is, I'd say actually now the state-of-the-art technique that most people do is they pre-render all of the screenshots and then just kind of go look through them all at once.
This was done with something like Eyewitness before, which was had its own problems making requests. It wasn't running Chrome headless.
Yeah, it's like Phantom.js, not
Phantom.js.
breaking on rendering certain pages, not working with like some of the latest JavaScript frameworks.
Yeah, now you can use Chrome headless browser to make those same requests and get screenshots, which is definitely better. But running them again from one system is an easy way to get blocked. It's an easy way to run out of memory on your own system, and you can't it doesn't scale to hundreds of thousands of screenshots.
Yeah, and you can actually still combine this technique with the signatures for path analysis. Maybe now you have all of your response data. You can grep through that, sort by content length, and still like apply some of those techniques. This still wasn't fast enough for us. It's still like a slow road to the ultimate goal, which is to find critical vulnerabilities or sensitive information disclosures.
Yeah, you can't sort by content length when you're making requests, making the same request across a bunch of different hosts. Like that doesn't work because everybody has a different 404 page.
Like 50,000 different responses that technique breaks down. So we asked ourselves, like, what if we could get to the same results? And what if we like didn't really need to spend the time writing the signatures and do all of that at scale? By scale, I mean like a large conglomerate global enterprise or like an entire government. We ran this on all the federal.gov sites earlier this week. It's really cool. I'll show you something like that later. Like make this basically a task easier to digest for humans. That's what I meant kind of when we were talking about let's automate this in a way so that the issues just come to us. We don't have to go look through 4,000 screenshots. So this is the process we ultimately came up with. Step 1 is that discovery, and having a really good set of valid targets to start with. Ideally, if you're going after something that's hosted on cloud infrastructure, going by domain and subdomain. And we're using another OWASP tool, Amass, and I'll talk about that in a second, to do this discovery. Helps us pull from a lot of open source intelligence gathering to get that targets list. Then
I think keeping that discovery portion running continuously is like a huge deal, and making sure that you really focus a lot of time on the discovery part, because finding additional targets is kind of at the road to
data divergence, and then inconsistency, and then headaches. So yeah, this definitely is something that runs on a regular basis, so that you always come back to fresh results. The other concept of this is like being able to request those paths from multiple IP addresses is pretty key to not getting blocked, to not bombarding any one system at a time. So really like distributing the load and therefore the amount of traffic to any one system in a given time frame is kind of essential for success.
Yeah, instead of sending the 30,000 requests to a single target, send one request to 30,000 targets so that you don't get blocked, essentially. Distribute it as much as possible so that you don't overload a single system.
And then pipeline right into those requests the ability to capture a screenshot, like Oscar said with headless Chrome. At that point, you're seeing exactly like what he was doing, loading them one at a time. Let's just get them all at once. And then the key step there is also applying a fuzzy hashing algorithm, which I'll go into the details of how it works, that allows you to sort the screenshots by visual similarity. There's a lot of
like the beginning screenshot, like the screenshots at the beginning of the list are basically like blank pages, and the
all
screenshots
white space,
at the very end of the list are very visually dense, high CSS. Like this is a
gradient usually.
Media company's like homepage, basically like a movie or something like that.
Like a movie poster kind of level of density and color. There's a lot of hashing algorithms out there to use for this. We're actually still kind of experimenting with which ones work best, and they actually work best in different circumstances. But what they're really designed for is like hashing of audio files or video files or image files. And so like these are well-known algorithms. We're just using it in a security context.
Yeah, and the idea is that with a regular like cryptographically secure hash, any one change in any one byte of the data that you're trying to hash changes the hash entirely, like the output entirely. And with these, it's small changes, make very small changes to the hash so that everything will group together.
Yeah, and the beauty of that is like the same way you would sort in Burp Intruder by content length and sort all of the things that are the same to one side, you're now doing that, but with screenshots. So everything that's white space goes to one end, everything that's complex goes to the other end, and you're really looking for the outliers. Then those are probably interesting to look at. Those are probably paths that you requested that may have a vulnerability or may have an exposure.
Yeah, at some point through the course of reviewing the screenshots from white to visually dense, you'll find pockets of all the images that are visually similar. That will be, these are all the .env files because they look exactly the same. And this is all the like git configs because they look very, very visually similar. And so as you go through, you'll kind of identify pockets of content that relate to what you're looking for. And since you might not know what you're signaturing on, you don't actually know what you're looking for before you're looking for it. But you'll see like something that's out of the ordinary, and you'll be able to flag it in on it, which is a really interesting way of doing.
There's multiple aspects of this process that he and I are just like so excited to share here, and so excited to keep developing because, but definitely one of the coolest is it just hacked an organization, but I had no idea what I was looking for when I started, which is actually typically how it goes. But now it's like find me a bunch of cool stuff. So to break this process down, the target discovery, as I mentioned, is another OWASP project that just came out in March of 2018. OWASP Mass, really recommend checking it out. It basically goes and uses a bunch of, I think like 3+ dozen open source intelligence gathering type of repos or aggregating data from these different sources by scraping websites, by looking at passive DNS, looking at other applications that are scanning the entire internet and capturing metadata about HTTP responses. And this ultimately lets us get a really good targets list. And it also can pull things from like certificate transparency logs, which people are, both attackers and people are using to kind of verify the changes that are happening to SSL certificates. And running that on a continuous and daily basis helps you just get these new targets as they're being created. To give you a better idea then, like of how we got that initial list, it is from like recursively pulling that data. And tomorrow, all of the IP addresses will change, and
new clients will buy an Elastic Beanstalk subdomain and host it there. So there's new things to find every day.
Yeah, and so the other aspects of the backend stack of how we're automating this involve, as Oscar mentioned, the headless Chrome, using Lambda functions to basically simulate running that headless Chrome, just as we were from our laptop. This is very inexpensive to just branch these out and have it scale to as many requests as we need, to as many targets as we need. We're using S3 storage to store millions. I think, how many millions of screenshots do we have now? Like over 150 million screenshots. taking the metadata that we're collecting from this, the response headers, the response bodies, storing that in Elasticsearch to make it easily retrievable or to identify specific issues. And then a little more experimental at this point, like just started using recognition. Yeah, you want to talk a little bit about that?
Yeah, so the recognition API from Amazon allows you to just take a image that's stored in an S3 bucket and send it to the API, and it will return to you just a giant JSON blob of all the text that it was able to read out of that image. And so you can kind of use that to help kind of lower the false positive rate in your data set, and saying any image that comes back with a custom 404 page that says 404 not found, that's not in text, but it's like an image of a 404 page or something along those lines, will be a lot more likely to be identified by this and can be taken out after the fact.
Use it to find login pages?
Yeah.
Sign up pages?
Yeah, you can use it for all kinds of different techniques. If you're looking at home pages of every single one of the 80,000 targets, which one of these targets have login pages that we can attack or that we can send our word list to?
Yeah, that may have been in the button image instead of in the alt text in HTML. And so ultimately, to give you a visualization of what it looks like making the request using Lambda functions and using AWS, I guess we used AWS to attack AWS. It's like the stop hitting yourself. Yeah.
So what we're seeing here is instead of all the traffic coming from a single IP and bombarding everything, it's kind of a slower, over time, distributed attack. Every one of these lines on the left side is a new IP. They get refreshed constantly. It's a new data set as new requests come in. So very difficult to block and a lot less likely to cause issues.
Yeah, and so this is much more like what a botnet attack would look like for even something like distributed denial of service, which we're trying to avoid here. So, but like we can actually randomize the targets in that list, especially when we're targeting like a large organization. So we're not banging on any one application too much at one time.
And since we're doing this on such a large scale and continuously, we can distribute the traffic on a much slower rate and have it still be very effective.
So after all these requests come back and we have screenshots of them, we then also do the perceptual analysis piece. So to break down like exactly that hashing algorithm works, the step one is we really just reduce the size of the image. It can go down to like much smaller than the human eye can see and a computer can still understand it. We also reduce the color. So we can go to just grayscale. Basically black, white, gray would be the only things that it has, because what we're actually looking for is differences between the pixels. Like
gradient differences.
Adjacent pixels, yeah. So what ends up happening is you basically kind of take this algorithm here that's at the bottom, like if pixel X is less than the pixel next to it in like a perceptual hashing algorithm, you either give it a 1 or a 0 and then convert that to an ASCII value and you have a 64-bit hash, and that becomes the hash that represents that image. And like Oscar said, like all white space,
all zeros.
Just basically zeros, maybe like a 1 at the end, or like an A or F or something like that.
But also, like an entirely black page would also be all zeros. But things like a gradient end up being basically all Fs. So. Yeah.
And something like an IIS default page all has the same hash.
So it's like a bunch of 7s.
So this is ultimately what it looks like. Like I said, we ran this across the government, all like loaded in 1,279 federal government, found the list on GitHub, it's like publicly available information, and basically grouped all the screenshots together. This is something that you've probably seen if you're a penetration tester doing network pen tests, a Cisco VPN endpoint that's trying to install like a Java applet or ActiveX. Basically being able to attack all those at once for specific CVEs or specific issues becomes a really powerful labor and time saving technique. And that's what we get out of being able to apply this.
Yeah, and actually this is pretty interesting. It's showing all other images that it found that were visually similar, and you can do that within a specific organization that you're looking at or across all organizations that you're tracking. And so like give me not only like, oh, I just found something interesting, who else or what other pages of this organization have that, and what other pages of every organization that's being tracked by this have that same image.
Yeah, and so I went to the other end of the gradient, which is basically, I'll back it up real quick. Looking at more visually complex, but recently a lot of these images just said, we're shut down for the foreseeable future. I just kind of want to pause right there. As like, any questions about that? I'd love to actually like have a conversation about this, like before we like kind of go into the next section of like where we want to take this in the future. No? Cool, at least.
Definitely.
Oh, thanks. Where we see this going next is like, since just looking at a screenshot is something that is a since it's something that is like pretty trivial for a human to just look at and quickly say like, this is vulnerable or this isn't vulnerable, we think this is a very applicable task for machine learning. Like very much, if machines can learn to drive a car, like
they can learn to look at a vuln.
Yeah, they can learn how to hack. And so like some use cases we've done with this so far is we've taken a look at like a perimeter of like a large media organization and said, let's put everything into 2 buckets, kind of like hot dog, not hot dog. Somebody watches Silicon Valley. And basically, we put things into either valid consumer facing or probably shouldn't be on the internet, probably a misconfiguration, or just
like an internal application that is exposed, or something
employees
that's used
only,
by a corporation. Yeah,
enterprise only, or just maybe you should move it behind the single sign-on the company just signed up for, but just didn't know it was exposed. And that has been like an amazing use case for just quickly breaking it down into those 2 categories. And that's pretty easily done by like, does it have the corporate logo up in the top left? Yeah. Does it have ads on it if it's a media company? Like that probably means it's valid consumer facing. There's a lot of consistency and a lot of lot going on typically in the things that are meant for customers depending on the organization. And I actually think applying like a machine model per organization is actually a really interesting concept. Like if you were to apply this across, something that's all under one big umbrella corp, they probably have somewhere in their page the logo, or they have like trademark of this company like somewhere in the page, and then you can basically train a machine to find that and know that it's
further the process. Yeah, speed up the process.
And especially as like you're continuously doing that discovery, like the goal is to something new comes online, let's immediately run it through this analysis and say, yes, this is allowed to be on the internet, or nope, this needs to be reviewed by an expert security analyst, and basically at that point know if they like this should be moved behind single sign-on or just taken offline, or if it has any critical vulnerabilities, we can get it bumped up in priority. And like we're kind of doing that manually at this point, but it's like right on the cusp. Maybe at Black Hat we'll do the machine learning demo, because where we're at now is more of like collaborative filtering. Like we're actually trying to keep that kind of like in this interface, ways to like tag things and be able to say like, all right, Oscar looked at this one today, let's flag it as, yep, that's something that should be there, that's legit, or nope, like I want to try to attack this, or have another member of my team attack this. Let's like basically look through this list together and solving that data divergence problem, solving the inconsistency problem, and ultimately making this way more efficient and more fun.
How much of the screenshots that you're evaluating comes down to experience and seeing those screenshots over and over?
A lot. And that's where like I'd say it's much easier to put someone in front of that console that has 10 plus years experience doing security assessments than it is someone that's in their first year. But the nice thing is it's easier, I'd say, to train someone to know what to identify, especially if you have like historical data to go off of. In one instance, like we actually worked with an organization that gave us all of their bug bounty reports, and we took the paths out of all of those and sent it through this automation and found other instances that weren't found by bug bounty and reported. And it was really trivial for like an analyst to say like, oh, I have the report in their ticketing system of how this was attacked before. Let's now also like reproduce those steps on this other endpoint that was missed, or maybe it came online subsequently.
Or maybe it was fixed and then regressed. That happens all the time.
I'm thinking from a machine learning perspective, like I had a friend of mine who actually wrote machine learning that would analyze images for assistive devices. Bear with me a second. No. Okay. And it would analyze web pages
for images, because when you do screen readers, it only analyzes text and alt text within the images. This actually analyzes the images using I work for Microsoft, so Microsoft's cognitive services, and would analyze that and be able to give audio response to people who need assistive capabilities. So I'm looking at those images, and I have to assume that if you have a large enough data set, you can pump that into machine learning, and common patterns can come out of those images, which means that you minimize the human interaction.
Absolutely. I'd say that one of the things that we're interested in doing, and like back to school for us, like both doing the Stanford machine learning course right now on Coursera. And if anyone here is an ML expert, I'd love to talk to you. But the like one of the algorithms that we're looking at applying is the unsupervised like learning algorithm that basically is going to put things into just more categories than 2. Like it's easy for us to do the consumer valid or shouldn't be on the internet categories, but maybe it's going to put it into 6 or 8 or 12 different groups that we can't even perceive with our little human brains to like know that these are all text-based, or these are all login pages, or these are all interfaces that are some other category we haven't thought of yet. And I think that has really interesting applications. And then I also think the supervised learning would be, let's like have the choices of what a person at a console or an analyst at a console like tags it as be fed to a machine to then train it of, okay, if you ever see something like this again, we know it's a high priority issue, or this one we don't really care about.
Exactly.
Yeah.
That's exactly what I was thinking.
Yeah. Teach a robot to see that page that was made in 1977 that you just come across and you're like, I know this is vulnerable.
Yeah. Yeah, that was most of the government sites actually. Any other questions? Well, cool.
Is this proprietary or open source, or?
So we realized like just giving this, like we love giving away tools and we love releasing tools. This one's a little complicated and actually comes with a price tag. So it would never be a free tool because cloud services cost money. And so yes to the question of currently proprietary, but plans to have a free service for this. Didn't quite get it ready and off the ground by this conference, but we're gonna
we're working on it.
Working on it, and we have some like professional engineering help that's gonna make it happen. And they basically are like the one possibility is like you give us your list of targets, you verify that you own them with like your Google Analytics tag manager ID or something like that, and then we run this analysis with either like a default word list or you upload a word list that maybe you upload information that you are curious if is exposed. And at that point, we do the heavy lifting and your output would be like an email when your job is done, click the link and you have a gallery of interesting things to look at now.
That's nice.
Oh, I think I'm gonna pass the mic back there.
Thank you. Hi, so you said that 80,000 targets is a good number for this, but what's the smallest project that would still be valuable to do learning with?
Yeah, so the one interesting thing is when you're doing the analysis from screenshots, we have actually been experimenting like, what if we only compare like 1 or 2 paths? And that has mixed results. They have to be unique, like they have to be visually unique paths. Like, do you want to talk a little bit like the admin?
Yeah, so one of the things that we do as part of the filtering down of what we had in the one page that was like, here's 880,000 requests that we made that turned into 52,000 screenshots. And from there, we were able to kind of take that data and remove all the outliers and remove the things that we think are 404s and end up with 4,000 screenshots to review. That process kind of relies on the fact that every one of the paths that we request, we assume are going to be visually different, like visually unique. So if you're making a request to to that git config or to that env file or to an admin login page or to something else, if those are all visually different, then if you ever get 2 screenshots that are the exact same from the same domain, then you can throw that whole set away because that's a false positive. It's like a custom 404 page. So one of the problems is that if you have a /admin and a /admin .php or admin/index.html, and those 2 pages are the same, then you'd throw it away. And so one of the kind of techniques that we were playing around with is taking, even though we're requesting, 30,000 paths, let's take a random sampling from those, and let's do the comparison of just the random sampling, so that even if we do have two paths that are visually similar, they won't get thrown out, or it's less likely. But I think the question was, can you do it with less than 88,000 hosts? And yeah, this technique works with a much smaller set. You could do it on a handful of domains and still get good results. Before we ran it against this, we ran it against like a couple demo smaller organizations with like a couple hundred domains, and the results end up actually being the same. You take the 100 targets, you pass in 100 paths, and then you take that 100,000 requests and you do the visual sorting, whatever comes back to 100, okay. It ends up actually kind of, no matter what the size of the data set is, you kind of get very similar reduction in size on every single request. So it's like a 10x reduction or like 1/10 of the amount of screenshots that you request result in 200, 1/10 of those result in like the things that you need to review, and then some portion of those end up being vulnerable if they are vulnerable. Yeah.
And I think another interesting aspect of this is we've really primarily experimented with this so far in like a breadth first approach of like the multiple targets, because we're finding a lot of issues with that technique. But as we wanted to like narrow our focus on a specific application, I think you could apply the same technique to doing deep analysis. One like potential activity there would be maybe take the common crawl data from like a major application, and then you have lots of paths, you have lots of parameters on those paths. Let's make requests to those, or maybe after we have done our own crawl, we could use that same perceptual hashing algorithm. Just probably going to be throwing out so many screenshots from that, but so what? It's AWS doing the heavy lifting, and at that point, you may be able to do like even fuzzing techniques with this. Can't say we've actually tried that yet, but I don't see why it wouldn't work. I think you could do deep analysis on one target, just doing so many like paths, like injection attacks and things like that, just like a burp intruder would, but like with this missing ingredient. Like whenever I saw that we could do screenshots at this scale, like this was like immediately what came to my mind. It was like, I think this has been like the missing ingredient for path brute forcing or content discovery for a long time. And so yeah, like I think that would work. Mm-hmm.
With 5 major rendering engines out in the wild right now, have you guys considered adding capabilities to check to see how the pages appear on different rendering engines, to see if there's other opportunities that perhaps Chrome headless may not present you? Because I know that especially in the enterprise, where there is Trident and you have Edge HTML, there's a big affinity towards that. That seems like an opportunity that...
Yeah, that could be, I'd say like, it may not be necessary for our end goal, being penetration testers, security assessors. Like exactly how it renders isn't as important as like, did I bubble up the security issues? I see that being like a really interesting use case for like quality assurance of like, does this render in Edge and Chrome and Firefox in the same way?
I'm thinking about finding bugs because...
Oh, okay.
No,
different user agent, different actual JavaScript engines. Yeah, absolutely. Like we haven't experimented with that, but I could see like doing like a mobile, simulating like a mobile like rendering client, finding like an app and having something load that we would have been completely missed by one pen tester, one laptop with their Firefox.
Yeah, I think it would really depend on the word list that you send to, right? If the word list that you're sending is like, here's go check for these change.txt, changelog.txt and stuff like that, the rendering engine might not make a lot of difference. But if you're looking for like admin login pages and stuff like that, you might definitely bubble up some interesting stuff.
That's where I was going to. There was a lot of back-end stuff that in my experience, what I've seen is the user agents cause different variations in terms of the appearance,
right?
The functionality, the capabilities, and so they also open up more opportunities because of that. So that's what I was curious.
We've seen a lot of them where you just, if you take the screenshot with Chrome, it'll just come back with like, go render this in Internet Explorer kind of thing. Yeah.
Exactly. So I'm just curious.
Yeah, I think that's like definitely a good future direction for the research as well. But to one point that Oscar just mentioned is like the word list is very essential. Like a quality word list will help you find things a lot more easily. And so we've also been experimenting with things like scraping all of exploit DB or all of CVE data that's out there, getting a list of every web path that's in Metasploit, and basically firing that all off without having to write those signatures. And it's just a huge increase in the
It's hard to find a lot of those paths in the wild to write the signature in the first place. Like, people are requesting it, but it's hard to know what's supposed to come back on a valid page. So,
or in some cases, we're just writing paths that are fingerprinting a service that, like, we know we'll have to do like multiple steps or post requests or things that are not idempotent, like that will actually like do a create or update or delete operation. And that becomes like, maybe we just request the CSS file that fingerprints that Oracle, or that WebLogic instance, so that we don't cause the damage with the automation, but we cause the damage with like actual fingers on the keyboard. Cool. Any other questions? In the back.
Yeah, so you're sourcing it. So can you hear me?
Yep.
Yeah.
So you're sourcing your data from like Gray Noise and Metasploit and like all the old school Dirtbuster paths, correct?
Haven't done some of the Dirtbuster paths, but yeah, for the most part, like our favorite, other than like homegrown ones, our favorite ones have been, there's actually a Git repo called PathBrute that someone's like automated.
And like FuzzDB and stuff.
FuzzDB, those types of things. And there's also one called CommonSpeak 2 that is actually using BigQuery to pull out every GitHub web app path and just kind of get some fresher content of like newer technology stacks. But for the most part, old school ones.
I think you guys should really consider contributing back somehow, because you're kind of pulling from a bunch of people's resources. So
Yeah.
aside from like a free service, maybe like a intelligence aspect even.
Yeah,
it would be good for the community.
Absolutely. Yeah, I'd actually love to we've actually contributed to Amass, since that's an OWASP open source project, and we've actually contributed some new features to that we're missing to pull this off. And I think that from a security research perspective, we just started to scratch the surface of what we can do with this. And so please, you can expect a lot more in the year to come.
Sure. Cool.
Cool. Any other questions?
I think we're good.
Cool. Thanks, everybody.